Okay, let's begin with the applications of linear approximations. Uh, as usual, we'll start with most canonical examples. So, one type of question that often arises is how can you estimate, the some root of a number if you happen to know that what's inside the root is very close to a perfect square or a cube or something like that. So this is an example. Let's start with this example. Okay, so how much greater the cube root of 8.1 is than cube root of 8? Use the result to approximate cube root of 8.1. Alright, for the solution. So what are we going to do with this example? So they are asking you to measure the change in a function. So what is a function here? So they're asking you to estimate. We're being asked. So the question asks us. We are being asked to estimate the change in f due to change in x at x naught equals 8. Right, so here the point is 8 and change in x. And so we're going to use a formula the approximating formula they were given at the beginning. So delta f can be estimated as the value of the derivative at the point x naught times delta x. Okay, but here, what is f? Here, f of x is the cube root of x. And so we want to know, so we want to know, or estimate, we want to estimate, estimate delta f, which in this case would correspond to the cube root of 8.1, and the cube root of 8. This implies that actually delta x, what is delta x? Delta x is 8.1 minus 8. So it's just 0.1. Right? So we know delta x. We need to know what is delta f. We need to know what is f prime. So what is f prime at x naught? Well, it turns out that f prime is for any x where it makes sense. It's the derivative of x to the 1/3. So 1/3 prime is 1/3 x to the 1/3 minus 1. So it's equal to 1/3 x to the minus 2/3. Okay, so So in this way, f prime of x naught will just be 1/3 of x naught to the minus 2/3. But in this case, x naught is equal to 8. Okay, so therefore we are asked to compute f prime at 8, which is 1/3 of 8 to the minus 2/3. And remember the rules of exponents. So this is the same as 1/3 x to the 1/3 to the minus 2. Okay, let's note something here. This is the cube root of 8. The cube root of 8 is 2, 2 to the minus 2. And that's why we chose this particular point here. We're approximating the cube root near the point 8 because we know already that the value of the function at that point is 2. We can compute it easily. But it so happens that because we're at a point where we can compute the actual value of the function, it is usually the case, and then the derivative at that point can also be computed here, like here. Even though the derivative spits out a minus 2 exponent, a minus 2/3, it's going to be written in terms of 8 to the 1/3, which is still computable. So we have to compute 1/3 times 2 to the minus 2, which is 1/4, 2 to 1 over 12. Okay, so we know we have the value of the derivative at the point 8, 1/12. And we have the value of the point, which is 8, x naught. Delta x, we know that is 0.1, so we have everything we need. So delta f, then delta f at that point is approximately equal to the value of f prime, which is 1/12, times the change in the value of x, which is 0.1. Okay, so that's the first part. Now we're asked to use this information here to estimate the new value, the value of f at the new point. But let's go back. So to estimate, so we're asked to estimate f at 8.1. Remember, this is just the cube root of 8.1. This is what we're asked to estimate. We simply move a term from here to the other side to get the linear approximation. So it's just f, or we can write it now as what it is. So the cube root of 8.1 minus the cube root of 8, which is 2, is approximately equal to 1/12 times 0.1. This is equal to 2. So the cube root of 8.1 is approximately equal to 2 plus 1/12 times 0.01. So this uses the linear approximation. So if we go back to the previous video, you'll see that this is nothing more than f at the point x naught, which was 8, plus f prime x naught times x minus x naught. X naught, remember, was 8, and x is equal to 8.1. Okay, so in this whole thing, it's just equal to L of x. So we're using the linear approximation here to compute the value of the cube root of 8.1. This is actually a very good approximation. We'll see more examples in the next videos.